So we're going to have a look at algebraic proof and how you can use algebra to prove any sort of algebraic statement, okay? You need to be aware whenever it comes to a GCSE exam question that if you try and substitute numbers in to prove anything, you will not be awarded any marks. So algebraic proof requires you to use algebra throughout, okay? So if we just have a look at the 5 things that you've got here, I want you to try and jot down some algebraic notation that you think would represent each of these criteria. And then when you think you know what to do, hit play and I will go through it with you. Okay, so to start off with, we need to think about 3 consecutive numbers. So consecutive means numbers that are next to one another, i.e. 5, 6, 7, 101, 102, 103. So there are a few different ways that you can do it, but often if you start with the first number as n, then the next number after that will be n plus 1, and the next number after that will be n plus 2. Now, in theory, you can do n minus 1, n plus 1. There are a variety of them, but these ones mean that you always deal with positives and it makes life a little bit easier. Okay, for something to be an even number, it needs to be a multiple of 2, and therefore, whatever number we think of, i.e. n, we can always make it even by multiplying it by 2. So any even number can be written as 2n. Question 3 then, so 2 consecutive odd numbers. So if we think of an odd number, it's always 1 after an even number or 1 before an even number, but again, trying to think positively. So therefore, our first odd number will be a multiple of 2 plus 1. And therefore, the next odd number after that, so remember if you're thinking 3 to 5, you will go up by 2. So your next consecutive odd number, you would go up by 2, giving us 2n plus 3. So question 4 says the sum of 2 consecutive even numbers. So sum means to add, so that's an important term there. And 2 consecutive even numbers, so the first even number will be 2n. And the second even number, remember, if you think about even numbers, the second one's going to be 2 after that, so it's going to be 2n plus 2. And we're asked to add them, and therefore when we were to simplify that, we would get 4n plus 2. So this would be our first even number, this would be our second even number, and then we've summed them. And then for question 5, the product of 2 consecutive numbers. So again, the key word here is product. That means to multiply. And therefore our 2 consecutive numbers would be n and n plus 1. And if we want to multiply them, we need to make sure that we're writing it clearly. So n bracket n plus 1, and then you would expand your brackets. Okay, so we're going to have a look at some more formal questions so that you can apply your knowledge from this page to be able to answer them. Okay, so if you want to have a look at this one, okay, give it a try and then hit play when you're ready for me to go through it with you. Right, so with this one, we're just trying to prove a statement. Okay, so to be able to do this, we need to make sure that the left-hand side can be written in the form of the right-hand side. So the first thing we want to do is to expand our brackets. So we know we've got n plus 7 squared. If we remember, that's going to be the same bracket written out twice. So you need to make sure that you are expanding it correctly. That will then give me n squared plus 7n, plus 7n plus 49, and then when we simplify that, we get n squared plus 14n plus 49. The second set of brackets is n plus 1 squared. So again, I'm going to write the brackets out twice so that I'm expanding properly, and we end up then with n squared plus n plus n plus 1, which will simplify to give me n squared plus 2n plus 1. And then I want to use this back in this format, so I'm actually asked to subtract 1 from the other. And you need to be really careful at this point. So my n plus 7 squared was n squared plus 14n plus 49. And we're taking away all of the solution to this one once we've expanded it. So we're going to put it in a bracket so that we're really careful with that. So n squared plus 2n plus 1. Okay, remember we're trying to make it look like this. At the moment it looks nothing like that. So if we think about simplifying then, we've got n squared plus 14n plus 49, and then we're going to minus everything that's in this bracket. So minus the n squared, minus the 2n, and minus the 1. We then simplify that. N squared minus n squared will cancel. 14n minus 2n will leave me with 12n, and 49 minus 1 will give me 48. So this now looks much closer to this, and if you can recognise then 12n and 48 have a common factor of 12, so I'm going to factorise that out to show that I can get the solution on the right hand side. Okay, so we're going to have a look at another question now. So if you can have a go at this one, see how far you can get, and then hit play when you're ready for me to go through it with you. Right, so this time we're trying to show that that expression is always a multiple of 4 for all positive integers, okay, of n. So our first job is, like the last question, expand all the brackets, but we're not aiming to get it to equal something specific this time. We just need to make sure that we can show it's a multiple of 4. So if we start with our first bracket, n plus 4 squared, so write out the brackets twice, and we end up then with n squared plus 4n plus 4n plus 16, and then when we simplify we get n squared plus 8n plus 16. And then the second bracket, n plus 2 squared, so again write them out twice and then expand them, so we end up with n squared plus 2n plus 2n plus 4, and simplify that, we get n squared plus 4n plus 4. Now if we go back to the actual expression, we need to subtract one from the other, so the n plus 4 squared was n squared plus 8n plus 16 minus the other expression in full, so we're going to put it in a bracket again to give us that, and then when we simplify we get n squared plus 8n plus 16, and we're going to subtract again everything in the bracket, so minus n squared minus 4n and minus 4. So the n squares will cancel, 8n minus 4n will leave me with 4n, and 16 minus 4 will give me 12. Okay, so it's now in its simplest form, except for the fact I need to prove it is a multiple of 4. For it to be a multiple of 4, we need to show that 4 is a factor. Okay, so we take 4 as our factor outside and we factorise it fully, and therefore we can state it is a multiple of 4. Okay, but you do need to do that factorising part at the end to show that it is a multiple of 4 to pick up full marks. Okay, we then have another question to have a look at. Okay, so if we have a look at this one, we want to prove the following, so that the sum of 3 consecutive odd numbers is always a multiple of 3. So start this one off, and then when you're ready for me to go through it, hit play. Okay, so when we're thinking about this one, we've got our key terms. So sum meant we needed to add them, and then 3 consecutive odd numbers. So we've got a few things to do there and to prove that it is a multiple of 3. So let's start off with our 3 consecutive odd numbers. Remember, an odd number is always 1 after an even number, and an even number is always a multiple of 2. So my first odd number is going to be 2n plus 1. My second odd number then will be 2n plus 3, and my third odd number will be 2n plus 5. And then the sum of them means I'm going to add those things together. Right, we then want to simplify, so 2n plus 2n plus 2n will give me 6n. 1 plus 3 gives me 4, plus 5 gives me 9. So that was quite nice and easy to simplify. We then just need to show it's a multiple of 3. So to do that, we need to take out the common factor of 3, so factorise it by 3, and we get 2n plus 3 in our brackets. Therefore, it is a multiple of 3. Okay, right, there's one more then to have a look at together. All right, so again, if you want to read through this one, give it a try, and then when you're ready for me to go through it, hit play again. So we need to prove the sum of the squares of any two consecutive even numbers is always a multiple of 4. So again, it's quite a bit going on this time. So the sum of the squares, two consecutive even numbers, and is a multiple of 4. So let's start off with our consecutive even numbers. We know an even number is then going to be a multiple of 2. So the first one is going to be 2n, and then the second even number after that one, so the next one will be 2n plus 2. We then want to sum them and the squares. So we want this one squared and this one squared, and then we want to add them. So we need to work out each bit. So if we think about it, if we do it over here, 2n times 2n will give me 4n squared. So I know that part. I can pop that in there. And then my 2n plus 2 squared means I need to write out that bracket twice and work out what the solution is. So I'm going to end up with 4n squared plus 4n plus 4n plus 4. And to simplify that, I get 4n squared plus 8n plus 4. So I can pop that in over here. So plus 4n squared plus 8n plus 4. If I then simplify that, I will end up with 8n squared plus 8n plus 4. Okay, it is fully simplified at this point, but I now need to show that it is a multiple of 4, and therefore I take out 4 as a factor and show that I'm left with 2n squared plus 2n plus 1, and then we just need to state it is a multiple of 4. Okay, so there's a few questions for you to have a try, and then let me know how you get on or if you need help with anything.